Hello, this is Greg D'Amico here, and I certainly want to welcome you warmly to Philosophy 101 and to our first substantive lecture here. So, to begin, I really want to just talk a bit about how I'm thinking about philosophy, the sort of nature of philosophy, or at least the way that I want to think about philosophy for this course. And I've got a couple things I want to say, so just a sort of quick outline here. The main thing that I want to say first is that I like to think about philosophy as comprising a set of tools for solving problems. Right? So, getting yourselves in sort of this mindset of solving puzzles, solving problems, that I think will be incredibly useful for us moving forward. We'll have to say a bit more about the type of problem and about the way we sort of go about attacking these problems in philosophy, but nevertheless, that problem solver's mindset is a good place to start. And then I also want to go on and sort of contrast philosophy a bit with science. Science is also in the business of answering questions or solving problems. And so we want to make sure that if we're going to think about philosophy in those similar terms, well, we still need to be able to distinguish it from science. Right? What is different about philosophy compared to science? Okay, so let's start with a couple sample problems here. This is just for fun. And if you look at the first module on Canvas, you will see that the first module is all about sample problems and so on. So this is actually our course here, and I've got a couple different problems here. This one is called bad inference. Okay. I apologize for the quality here. These are taken from a book that's now out of print called Martin Gardner's book, Aha, Gotcha. Lots of fun little paradoxes and puzzles to think about. Now I'm going to zoom in a bit here so that we can actually read this. You can see that this page is called Jumping to Conclusions. Okay. So here's one example here. Statistics show that most car accidents occur when cars travel at moderate speeds and that very few accidents occur at speeds of more than 150 kilometers per hour. Okay. Does this mean it is safer to drive at higher speeds? Now that's supposed to sound like sort of a paradox, right? You think about all the accidents that occur in traffic and you realize, gee, there are very few that occur at these really high speeds. Does that mean that we ought to be driving faster, right? Does that mean that actually it's safer if you drive really fast? And of course, no, that's not the conclusion we want to draw, right? The problem here is, well, there are very few cases at all of people driving that fast, right? And so if we're just comparing pure numbers of accidents, we have a sort of dramatic difference in the sample sizes between cases where cars are moving at moderate speeds and cases where cars are moving at speeds of more than 150 kilometers per hour. That's about, I don't know, that's something like 95 miles an hour. And so, right, of course there are a few accidents at that speed because there are just few cases in general of people moving that fast. Right? So again, this is just sort of to prime you for thinking about puzzles, thinking about problems, and to prime you for thinking analytically about them, right? Here's a conclusion I'm trying to draw. Aha, it's safe to drive at high speeds. But very often, right, the philosopher is going to say, well, wait a minute. Are we really entitled to that conclusion? That's why this is called bad inference, right? This is actually a bad inference to draw. Okay. Here's another one. A research study showed that children with big feet could spell better than those with small feet. Does this mean that the size of one's foot is a measure of one's ability to spell? Here's a correlation. Bigger feet, better spelling. Okay. Now, obviously, we've probably heard this. It's sort of in the common culture at this point. Correlation is not causation, right? And that is exactly the inference that we're trying to draw here. That somehow having big feet is a cause of good spelling. And of course, that's not true. What's going on here? Well, there's some third factor that's really the common cause both of having bigger feet and of having a better ability to spell, which is children aging. Right? The older you get, many things happen to you as you get older. Two of those things that happen to you are your feet get bigger and your spelling ability gets better. Right? So those two things are common effects of a third feature which is not mentioned here, and that's really the ultimate explanation of this phenomenon here. Okay? And I want to go back. There's a whole litany of sample puzzles here. I just want to go back and show you one more here. So if we go back home, I'm going to take a look at this Bemke puzzle here. Okay, a nice little puzzle. Okay, you live in a country with a terribly corrupt postal service. Unfortunately, personal limitations and the lack of a presence of independent mail couriers mean that, for most people, it's still the only way to get something delivered domestically. Okay, corrupt postal service. And you do indeed have something to be delivered, for you've promised to send your friend a diamond, and the delivery date you've set is fast approaching. Your friend lives on the other side of the country, so the postal service will be the only option. The good news is that Bemke, a local manufacturer of delivery boxes and locks, offers a promise that whatever you send with their products will survive the thieves who work for the postal service. Okay? Bemke sells indestructible boxes of all sizes. Because the post office will likely steal anything in an unlocked box, Bemke also sells locks with keys. The locks are also indestructible, each unique and sold with a single key. Okay? A single Bemke box can accommodate multiple locks. All Bemke products are widely available throughout the country. Now, given that setup, there is in fact a foolproof way to get the diamond to your friend with whom you've been in recent communication about the trouble. Can you figure it out? Okay. So that's the challenge. How do I get this diamond to my friend? So you might think, well, I could send the diamond in an unlocked box, but of course, in that case, the post office will just steal the diamond. I could put a lock on it, but then I'm the one with the key, and so my friend can't open it. Right? So the initial attempts at trying to solve this are not going to work, but there is a way to do it. So that's your challenge. This is just for fun. I am not going to give you the answer yet. I will in the next lecture, but I hope you enjoy thinking about that puzzle. Okay.